Today we're going to look at the idea of a one-sided limit. Everything that you've been doing so far has been a two-sided limit, meaning that you've got to come to the same value on both the left and the right-hand side. So when you looked at your limits before with the table or the graph, they had to come to the same point on both the numbers smaller than your c-value and larger than your c-value, which is what we see in the first example here. The limit as x approaches 0 of f of x, we can say that this does not exist, so DNE. And the reason for that is as I approach 0 over here, I'm getting closer and closer to -4. But if I approach 0 from up here, I'm getting closer and closer to 0. So the fact that -4 and 0 aren't the same point means the limit does not exist. Because as you go from the right, the y values get closer to 0, which we see right here. And then as we approach x, or as x approaches 0 from the left, the y values go to -4, which we see right here. This is a two-sided limit because we need to have both sides come to the same point. However, we can look at a one-sided limit, which is what today's lesson is. If I wanted to do a one-sided limit, I could use this notation. The limit as x approaches c with a minus sign up here of f of x. This is saying the limit as x approaches c from the left. Or we could say the limit as x approaches c from the right. And this notation is from the right. Everything we've done so far has looked like this. The limit as x approaches c of f of x. When there's no designation up here of a plus or minus sign, that means I'm using a two-sided limit, which means both sides need to converge to the same value. So going back to this first example right here, if I were to look at the limit as x approaches 0 from the left of f of x, we would say it's -4. However, if we look at the limit as x approaches 0 from the right, it's going to be 0. And then if I have the limit as x approaches 0, which is a two-sided limit, you're going to say this does not exist because the two values are not the same. So basically a one-sided limit is just splitting the two-sided limits in half and taking each side as its own problem. So looking at this piecewise function, let's see what happens here. 1 over x squared. It's going to look something like this. And if you're wondering, where did that come from? Well, let's just go back to our original parent functions. 1 over x looked something like this. And then if I make it y equals 1 over x squared, that squared piece just means that we are going to have everything being in the positive quadrants. I'm only going to put the second quadrant piece down because I'm talking about the parts that are less than 0 on the x-axis. The second part, when x is greater than or equal to 0, we've got the line x plus 1, which is that. So as I evaluate the limit, as x approaches 0 from the left, which is what that minus sign means up here, that means from the left, I am going from the left-hand side. So this would be the part that's to the left of 0. And I can see that's going to be going up to positive infinity. We could also say that this limit does not exist because infinity is a concept, not a number. So either one would be fine. The second one here, let's make this a plus sign. The limit as x approaches 0 from the right of f of x. Well, if I'm going to the right, which is slightly larger than 0, I can see that I am approaching 1. So the limit as x approaches 0 from the left did not exist. The limit as x approaches 0 from the right is 1. And then if I were to look at the limit as x approaches 0, which is the two-sided limit, you would also say this does not exist because they do not converge to the same values.